Hi, and welcome to Dr. V's AP Chemistry webcast. Today we're discussing hybridization. Here's what I'd like to talk about in this webcast. First, I want to describe three categories of hybrid orbitals: sp orbitals, sp2 orbitals, and sp3 orbitals. And then I want to show how these hybrid orbitals are related to the geometry around the central atom. And of course, we're going to do practice problems. In case you're wondering why we need to discuss this hybridization idea at all, is that it gives us a way to reconcile molecular geometries with what we know about atomic orbitals. We know only the valence electrons are getting involved in bonding, and we know these orbitals on the atomic level are s orbitals and p orbitals. We have d and f orbitals too, but a lot of times we're talking about our s and p electrons in these spherical and dumbbell-shaped electron clouds. So how do we take these orientations and get to a tetrahedral geometry? How do we get to a linear geometry? How do we have a trigonal planar geometry when these are our atomic orbitals? And hybridization is one way to discuss that. We know in a linear geometry, there are two electron domains around the central atom. One way we can put this all together is to take an s orbital and a p orbital, two atomic orbitals, and we can add them up because they're mathematical equations, and then divide them by 2 to make two hybrid orbitals. And we're calling these hybrid orbitals sp hybrids. So I had two orbitals, I make two orbitals, and they're both around the same atom. And they have a different shape, and they have a different orientation. So we've got these two hybrid sp orbitals, and if we look at how they're oriented around the atom, superimposed on each other, we see they've got that 180-degree bond angle that we associate with a linear geometry. So a linear geometry is telling you there's sp hybridization. If you've got two electron domains around the central atom, you've got sp hybridization. What if we have trigonal planar geometry around the central atom, where we have three electron domains? To do this, we're going to take one s orbital and two p orbitals from the same atom. So I've got three atomic orbitals. I'm going to add them up and divide them by 3 to make three hybrid orbitals. And these hybrid orbitals are called sp2 hybrids, because I had an S and a P and a P. So the names aren't that creative, but they do tell us what's going on. And again, these are all around the same atom. And it does mean that there's one unhybridized p orbital on the atom that wasn't used. That ends up becoming important in other topics in bonding. We've got our three sp2 hybrid orbitals. Here they are all together, all around the same atom, where I'm just focusing on the big lobes. But we can see we've got these sp2 orbitals, and they're at 120 degrees from each other, which is consistent with that geometry that we see for trigonal planar molecules. Big picture: trigonal planar geometry, sp2 hybridization. Three electron domains around your central atom, sp2 hybridization. How do we put this all together for a tetrahedral geometry, where we have 4 electron domains around that central atom? Well, I'm going to need to take 4 atomic orbitals, my s and p and p and p orbitals, and add them up and divide them by 4, and I'm going to make 4 hybrid orbitals that we call sp3 hybrids. When we look at these 4 hybrid orbitals all superimposed on each other, we see that classic tetrahedral geometry, those 109.5 degree bond angles, which are so important, the most important bond angle in AP chemistry. Big picture: a tetrahedral geometry around a central atom is sp3 hybridization. 4 electron domains around a central atom, sp3 hybridization. Now, I think students understand hybridization best when they see where it's coming from, but in the end, what you really need to know is that if you have 2 electron domains around the central atom, it's going to be a linear geometry. The bond angle will be 180 degrees. It will be sp hybridization. If there are 3 electron domains around that central atom, that trigonal planar geometry, 120-degree bond angles, we're talking about sp2 hybridization. And if there are 4 electron domains around the central atom, we're talking about a tetrahedral electron domain geometry with 109.5 degree bond angles and sp3 hybridization. You don't have to know what hybridization means in AP chemistry, but you have to memorize this table. If you know the hybridization, you know the electron domain geometry. If you know the number of electron domains around the central atom, you know the hybridization. If you know this table, you'll be good to go. Practice problems are the key to success. What's the hybridization around the highlighted atom? So you're given a Lewis structure. I'm telling you, I want to know the hybridization around the nitrogen. There are 3 electron domains around the nitrogen, right? I have 3 bonded atoms, and therefore the nitrogen must be sp2 hybridized. What's the hybridization around the highlighted carbon here? I see 2 electron domains around the carbon, and therefore this carbon is sp hybridized. You know, a good strategy always with problems is to try it on your own, so pause the video, figure it out, and then let the video resume to check your answer. So the phosphorus here, what's its hybridization? There are 4 electron domains around that phosphorus, and therefore that phosphorus is sp3 hybridized. There are 3 carbons in this molecule. I want the one that's highlighted in lilac. What's its hybridization? Well, I see 2 electron domains around that carbon, and therefore it must be sp hybridized. And in our last structure, our last problem for the webcast, the hybridization around this carbon atom, I see 4 electron domains around the carbon, and therefore it's sp3 hybridized. So any Lewis structure, you should be able to look at that and determine based on the number of electron domains what its hybridization is for any atom. And here's a final recap. sp2 hybridization is an atom with 2 electron domains around it. sp2 hybridization has 3 electron domains around that central atom. sp3 hybridization, there's 4 electron domains around that central atom. In AP chemistry, we don't talk about hybridization for any atom with more than 4 electron domains around it. I want to remind you to subscribe to my channel so you get all my latest videos. Study chemistry every day. That's how you get better.